What we have prepared so far is just some basic protected mode setup, some descriptor tables crafted manually, including interrupt descriptor table to let us handle exceptions, and our exception handler just displays decimal number of that exception centered on the screen, text mode screen, so that when we do something wrong, like here trying to read from above limit of data segment, then the exception should happen. And we have exception 13. Now, the question you might be asking is how the exception handler works if there is no stack set up. We have not set up any stack for protected mode, and any interrupt needs to store return address on the stack. We are not returning here, but we could do an iret. This would probably cause the exception once again. It might restart the instruction that caused the exception. But anyway, we could do that. But how would that work? Well, there is detail that I mentioned when we are setting up protected mode. What allows us to, after we enable protected mode, we still are able to execute instruction, well, in real mode, as if in real mode, because until we reload code selector CS, code segment selector, it still has in hidden cache the previous settings for that segment. And the same is true for the stack. This is how it looks in CPU. The register that we see and access with assembly instructions is this visible selector, 16-bit, but CPU also contains this hidden descriptor, so that CPU does not need to access descriptor table each time. It just caches this information. When we modify selector, then we also update the descriptor according to current state of descriptor table. So as long as we do not modify stack segment selector, it is still going to work as it worked in real mode, because this hidden descriptor is not going to be updated. But of course, we should set up some stack for protected mode. We cannot just use it like this forever. It is only a curiosity that it works this way, and this feature is going to become more handy in future on 386, when we can utilize this feature to set up some additional interesting modes like flat real mode, unreal mode. But before we move on to add more segments, we should make it easier for ourselves. So I'm going to design some macros that would compute various offsets for us and count limits automatically. Let's leave it for the purpose of comparing. Oh, I know this. This file manager. Has an option. Never mind, I wanted to sort files differently, but for comparing, but we might do without it. So let's make a macro for descriptor table. We would use it like this. So we should define another macro for ending this table. This macro should remove itself after use, and we can define limit. In this way. So when we set up limits here, we can use the value that was computed for us. Oh, I have a typo here. Okay, this should mostly leave our executable unchanged. Well, this is a very simple macro for start, but let's make it more interesting. Let's now make a macro that is going to be only available here inside, so we purge it at the end of table. For defining descriptors, attributes default value 0, and we might want to be able to define limit and base, but we can just leave them at default values also. So the structure of the descriptor is first limit, then base on 3 bytes, so let's use this directive of FastG, then single byte of attribute and reserved word not used on 286. So now we can rewrite this. Well, for null descriptor we can just use all default values. Then code descriptor this attributes. We do not need to set up base and limit here because we set up them in code with these calls. And for IDT, attribute, then limit is in this case offset, and base in this case is selector. But we can use the same macro and it should work anyway. Let's try it. Does it work? Yes. In fact, the file should be unchanged. But I have this minimalistic DOS here that does not... I do not have most of the tools, so I do not have file compare. There is something to compare in this file manager, but... Well, there is compare directories. Alright, let's compare content. Yes, the com file is identical. Okay, so we have a way to compare them. All the changes that we make through macros now should not change the executable, not a single bit. So next step would be to label these descriptors so that we no longer have to use hard-coded values like here 3 times 8, 2 times 8, etc. So let's make a struct macro. And struct. This is a special macro in case of FASM or FASMG that is used by writing label before macro name. And then we are not going to define this label directly, just some other fields. This dot in the beginning inside struct macro means that this is going to be name of the struct dot, and this is a child symbol. So address of the descriptor, this is just going to be current offset, current address. While selector is going to be offset relative to the table. Because let's take another look at the manual. Something's not working for me. Wait a second, I might need to... So here we see that selector has index in descriptor table shifted 3 bits up, and if we ignore the lower bits, and for now we are going to have them zeroed, then selector is equal to index multiplied by 8, because shift by 3 bits is multiplying by 8. And because descriptor is also 8 bytes in size, then selector is in fact the same as offset in the descriptor table. So we can do it this way, and this defines a selector assuming that 3 lower bits are zeroed, but then we can add these bits later if we need them. And index is going to be this shift right 3 bits. Now we can name our descriptors. Some of the shortcuts do not work properly here in Box for me. Maybe I should just switch back to DOSBox to edit the file. So now here, instead of this, we can just use address to the descriptor that has been computed for us. Here also, as I mentioned previous times, the structure of register GDTR or IDTR is in fact the same as initial portion of descriptor, so we can just load the same data from descriptor and do not have to set it up elsewhere. And here we can use selector symbol. Oh, and also here. And there is also selector in exception table. Let's space it up a little. Oh, there is some difference. What did we break? Well, the size of the file is different. But why should it be? Yeah, some values have changed. Oh, because I forgot. I forgot to define actual descriptor data here in structure. We have defined these values but did not define the actual data. So I called this macro and put the data there. Yeah, the size is now the same. The file is identical, so far so good. I'm going to move these macros somewhere else. So next step would be to allow ourselves to define some segments easier. For example, we would like to write it this way. Again, we define macro in such way that it allows to end itself and then purges the unnecessary child macros. And it should define its limit. This way. So now here we can use this data and data limit variable. Something has changed this time. Oh yeah, of course it changed. Limit is -1, so this is in fact not semantically it should be something different because we want the size of this message. Okay, we can stop comparing. This is the same executable, but cleared up a little with macros. Oh, we can also allow ourselves to define addresses within such segment here. So let's modify macro once more. Start from offset 0 and then just so then we limit is then just this value, and we restore previous addressing when we end this segment. This way we can now write it like this. So we can now use variables within our data protected mode data segment. Let's try it. Yeah, it still works correctly. Yeah, it should all be easier now. Also, for clarity, we could replace these values. Oh, this works. Yeah, really, some shortcuts are not working properly in Box. Let's take another look here. We can perhaps divide it to separate various interesting bits. So this was present bit, this was DPL. This indicates that this is a segment descriptor, this indicates that this is code or data descriptor. And for code, this bit means that it is readable code, and for data, this bit means that this is writable data. And for interrupt gate, this should all be 0011, and this is type trap or interrupt. Let's do a sanity check. Yeah, it still works. And let's perhaps make some variables for this. Well, not even variables, but symbols. Okay, and now is the time when we can start adding more descriptors easily. Yeah, it seems that box is intercepting some of my shortcuts. I may need to take a look at this later. Oh, and now let's set up it in this same segment that we have our original stack. In comprogram, stack runs from the top of the segment, and there is something in the 286 architecture that might help us with it. The attributes of data segment have this field called expansion direction, and if we set this bit to 1, then data segment is going to expand from top to bottom instead of normal from bottom to top. So when we set the limit, the portion of segment that is accessible is the other one that it would be usually, so the one above limit and not the one up to limit. So let's use this special attribute for stack. And now we can just make a label for the top of our code and data. And set up the stack in such a way that all the remaining portion of the segment is used for stack. We can perhaps set up stack here. Starting from the very top. Oh, my mistake. Yeah, this is our limit, and this should be just 0. Because we use the same segment. Does it work? Yes, it does. So now we have a usable protected mode stack, because if it was not a correct stack, then we would not get to this message. Or the interrupt, the exception handler would cause some double fault, probably. And now, as we have all the macros ready and we are able to easily add new descriptors, we can finally start talking about protection mechanism and how protected mode allows to really isolate processes from each other and protect from malicious processes, especially. So I think we are going to talk about the protection finally in detail next time.